Welcome viewers. In this video we will see the decision making and looping statement available in the C program. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, decision making and looping. There are three types available: while statement, do statement and for statement. These three are the decision making and looping. After taking the decision, it is executed repeatedly. That's why it's called a looping. Looping means is given executed repeatedly. So in this video we'll see the while statement. What is the syntax and what is the explanation of the while statement? The syntax is while test condition, open the brace, body of the loop, close the brace. That is while the condition is verified. If the condition is satisfied, if the condition is true, the body of the loop, that is set of statements available between the braces, are executed. If the condition is not true, it will not be executed. If the condition is true, it will be executed. Again it will check the condition again and again until the condition is false. Until the condition is false, it will be executed, right? So it is a entry level. It is also called a entry level loop. Entry level means in the entry itself we are checking the condition. Another statement is do statement. We are asking to do. Do means it will execute the statement, then only it will check the condition. That is called a exit level statement. This is the entry level statement. Now we will see the description. The while is an entry controlled loop statement. So entry level we are checking the condition. The test condition is evaluated, and if the test condition is true, then the body of the loop is executed. After execution of the body, the test condition is once again evaluated, and if it is true, the body of is executed once again. Some same process continues until the test condition finally become false. Then the control is transferred to the out of the loop. So it will verify the condition. If the condition is true, body of the loop is executed. Again it is tested. Again if it is true means executed again and again until it become false. After that it will go out of the loop, right? So it is a entry control loop statement. Now we'll see the example program for while loop for reversing the digits of a given number. The given number, the digit should be reversed. For example, 451 means we have to reverse at 154. All the digits are reversed. Now we'll see the example program for reversing the digits of a given number. Welcome viewers. In this video we'll see the how to reverse a number, program to reverse a number using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, program to reverse a given number using the C programming language. Let us consider the number n equal to 4589. We have to reverse the digits, that is 9854, 9854. We have to reverse the entire digit, right? 4589 means it goes in a reverse order, 9854, right? We have to reverse. This is the program. Right. Then how to reverse this? First what we need? First 4589 means we have to reverse at 9854. So we need a number 9. The last digit we need. So how to extract the last digit from this number? This is a given number 4589. So by using the modulo division. Modulo division means it will give the remainder. So it is divided by 10. After that it will give the remainder, so that we can get the last digit, right? The division means it will give the quotient value. Modulo division means it will give the remainder value. So by extracting 9, if you divide by 10, it will give the remainder value. So 4589, if you divide by 10, it is 4580. 80 times it will go. The remainder value is 9. So that we can extract this 9 value, right? Now how to multiply this? So we have one value. Initially it is 0 because 9 means the next digit will be 98. So increase by 10. The next digit will be 5. Increase by 100. Next digit will be 4. Increased by 1000. So the position is keep on changes. This is the first position. Second position means 10 value. 3 position means 100 value, 1000 value. The position keep on changes. So that we are multiply by 10. So initially we kept as 0, right? We are having one value 0, that's multiplied by 10 plus 9. For that we are adding 9. So initially 0, so 0 into 10 0, 0 plus 9, we have the value 9. So this is the reverse number. We are getting the first digit now. I will go to the second and third digits, right? Now this 4589 we extracted the 9. Now we need to extract the 8. So we have to reduce this value. 4589 should be reduced to 4458. We have to reduce into 3 digits. Then only we can extract 8. For that what we are doing, it is divided by 10. Already we told divided by 10 means it will give modulo. This is the modulo division, this is the divider. Quotient will be there. So 4589 divided by 10 means it goes 4458 times. Right? So it gives the remainder. This gives the quotient value. Right. So first what we are doing, we are divide with the modulo division. We got the remainder. That remainder is added with one more value 0 into 10 plus that remainder value. Then the number is divided by 10 so that it is reduced to 3 digits. Now we have to repeat the same process. Now this number is available currently. So this number is divided by 10, modulo division by 10, so that we got 8, second digit we got. Now see this. This number is already available. 9 into 10 plus 8. So that it becomes 98. If we add 9 plus 8 becomes 17. But we have 9 is the first position, 8 is the second position. So that 9 is added, multiplied with 10, then 8 is added. So it becomes 98. Again is divided. 458 divided by 10 means it goes 45 times. Right? So that now 3 digits now changed to 2 digits. Right? Now we go to the next again. 45 percentage 10. So it is the remainder is 5 is available. Again 98 is there. 98 into 10 plus 5. Then only 985. It become 985. Then 45 by 10 it is 4. Now the 2 digit is now reduced to the single digit. Right? It is reduced to single digit. Now one more process is there. 4 percentage 10. The remainder is 4. It is not going. It is only remainder is 10. Already 985 is available. 985 into 10 plus 4. So 9854. This is our required answer. So as usual we have to divide by 10. So it is 0. It is not divided. Once it is 0, once it reaches 0, we can stop the process. Right? Until it reaches the 0, we can stop the process. Right? What we are doing first, we are finding the remainder value by divided by 10. That remainder is added with multiplied by 10. Again it is divided in order to reduce the digit. So this process is repeated until while dividing, if it reaches the 0 value, the process is stopped. Right? Now we'll see the program. So the main program, void main. So include file, header files you can include as default stdio.h, conio.h. Then integer n, the variable declaration. This is a number, given number. This is the revised number. This is the 4589 is the n. We need to find the reverse number, 9854. This is a remainder. We have one remainder value is there. So we have one more variable remainder. Right? So n is the given number. Reverse is the reversing the digit. It's the answer. For storing the remainder, we have one variable remainder. After clear screen, we ask the user to enter the number. So user will enter the number using the scanf statement. The number is scanned and it is stored in and n, address of n. Right? It is available. The user what enter the number is available in n. Right? So initially the reverse is kept as 0. See this already initially it is 0. So reverse, this is the answer. Answer initially we kept as 0. Here we are using while loop. While n not equal to 0. Because while doing this process, when we need to stop, while dividing by 10, if it is 0, we can stop the process. If it is not equal to 0, we can continue the process. Right? So if it is not equal to 0, we can continue the process. So that while n not equal to 0, we can do this process. While n equal to 0 means we can stop the process. Right. What we need to do? Remainder equal to n percentage 10. That is the first process. You have to divide by 10 modulo division and find the remainder. So here remainder will be available. So the reverse equal to reverse into 10 plus remainder. We already say that reverse is already 0. 0 into 10 means 0 plus the reverse when the remainder will be added. This is the first process, remainder will be added. Then what we need to do? N equal to n by 10. This is divided by 10. So that 458 become 45. Right. So these three process we are doing inside the loop. First one, finding the remainder using modulo operator, then adding the value by multiply by 10, then only the digit will increase, then divide by 10 in order to reduce the digit. So these three process was done inside the loop. This process will be repeated until n become 0. If n is not equal to 0, the process will continue. Right. Now we'll take one simple example. 75. We'll take 75. We need to convert into 57. Right. We'll take this 2-digit value. Simple example. Right. What is the reverse? Reverse is 0. Initially reverse is 0. First finding, we are finding the remainder. Remainder equal to n. N is 57 percentage 10. What is the value? It will give 5. Right. The remainder 75 percentage 10 means it goes 7 times. The remainder is 5. What is the value available here? Reverse equal to reverse into 10 plus remainder. Right. Reverse is already 0 into 10 plus the remainder value is 5. That is equal to 5. Now the reverse number is 5. Right. Now what we need to do? We have to divide. Right. 75 divided by 10. So it become 7. Right. So this is the one process. We have to repeat the same process again. Right. We have to find that remainder equal to, this is a remainder, not as remainder. Remainder equal to 7 percentage 10. That is 7. It's not goes anytime. The remainder is 7. You have to perform this operation. Right. Now the reverse value is 5. 5 into 10 plus 7. So 57. So this is our required answer. What we got. Right. So again we need to divide. That 7 divided by 10 is 0. It's not going. If it is 0, we can stop the process. We got this answer and we can stop the process. Right. So this is one simple example. 57. 75 converted into 57. 75 first divided by 2, that is the remainder. We got 5. That 5 is added with the reverse, so that the reverse become 5. Initially 0. Then 75 is divided by 10, it becomes 7. Now 7 is given with the modulo division 10, so that it is 7. That is added with this expression, so it becomes 57. Is the required answer. The 7 is again divided by 10, it becomes 0. When it is 0, we can stop the process. This is our required answer. So that answer will be printed. The reversed number is percentage D REB. The answer is available in reverse. After get CH, we can close the program. So in this program, how to reverse a digit using C program we discussed. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.